Hello guys, welcome back again. I'll be doing a video today about ARA packages and specifically how to invoke the help functions within the ARA packages, how to navigate through these packages and get what you want. I will not dwell much on how to use these packages or how to install these packages, but I'll just take you through the basics because after installing your ARA software and going through or learning the the programming syntax, how to write a function, how to loop, how to do everything. At the end of the day, you may find that the functionalities or the facilities that are built within the ARA base functions are not real enough to suit your needs of analyzing data. For instance, for me, I'm an ecologist. Basically, in most cases, I deal with data, large scale data. And then this data, sometimes I want to use specific packages. So how do you now deal with packages? Because each package comes with its own functions, which you really don't know. So the best way is to invoke some kind of help functions within the ARA. You can use the ARA base or ARA Studio. So we're going to start. But first of all, before we start, you need to know that ARA packages, this is a group of functions that are bundled together conveniently. So since they're a group of functions, that means these functions are suited or are tailored for a particular need. But most of the packages really work together with other packages. For instance, you're going to use PartStat package, you may need the map tool package or just a package at the same time, maybe to import the layers and stuff, which you use as windows in that case. So now, the best way is these packages are developed by our community, and they have repositories or servers where they are stored, how you can access them. Sometimes we call these ones mirrors. So these servers may be local or international. As you can see, if you go and look at, we can have, it's like CRAN. CRAN is one of the repository which has a well-documented number of packages. And so when you install, maybe your ARA may try to tell you to select a particular kind of CRAN mirror, which is basically a server. You may select Chile, China. But I also have GitHub. We have GitHub and then by conductor. GitHub is not specifically for ARA packages. I mean, it's not specifically for ARA, but it's like for different kind of software. It's generally and so far the leading. But then it's also good for ARA's repository of packages. And bioconductor is basically for biostatisticians. I will not go much into details of that, but today I want to show you how to use the help function, is how to navigate through data, how to look at the existing data. Because if you're preparing a data frame, you need to look at how these data frames, which are fully packaged in those packages, are arranged such that you can also arrange your own data for analysis. Okay, so the first way is to install packages, is to call these functions, install.packages into a package you want. I may need a package called mass. But you have to know the name of the package that you're going to use. Okay, so basically, if you want to analyze kind of data, if you want to regression analysis or correlation analysis, the best thing you do is go on to online and select and type in other packages for analysis of regression. It will bring a lot of stuff. So when it brings a lot of stuff, so you know the packages that are there. Or you may try to go into a review because there are many packages, or you may try to type in a review of other packages and you see how people rate these packages together, and then you make a choice. Okay, so this is a function for installing the package, and when I enter or I click run, that's what it does. It is installing the package. Alternatively, I can install many packages at a go. So I can do install packages. I can install packages like this. What I'm going to do is make a string of vectors of these packages. So I'll do my, I'll first install mass. And then I'll say I'm going to install another one called map tools. Okay, and I click on enter. So what it does is to install all of them, but here is not writable. Would you like to use a personal library instead? Yes. You see, it install all of them. And then when you want to remove the package, now I'm gonna remove the package. Like in uninstalling the package, it's remove that package. If you're in RStudio, it already brings for you. So I'll do that and remove the package mass. That's it. So it has removed. So when we load a package, or when we install a package, we install mass again. When we install a package, what we do is we load it through using the library function, okay? So when you use the library function, this one doesn't need a quote or anything to make it, it doesn't need to specify whether it's a vector, just use without quotes. So you can say mass, you now calling, sorry, okay. So the library, that means when we install it, it's now, when we install it, it is stored into a temporary folder, which now becomes the library. Now there is a confusion here. Most people don't know what a library is and what a package is. A package, as I said, is a group of functions conveniently bundled together. So these functions have like common programming language. It may not be either per se, but it is a function, a group of functions that can help you analyze the data. But then when you go to the library, that's where is the local repository of those functions. So that's the library. So now we call library, and then we can invoke or call back the functions of mass. So, but then hardly we can provide a clear differentiation between these two. The library is like a library is like a real library when you go to your library or a school or university. And then when you go into the library, you have the books. The books are the packages. Okay, I think that is now very, very clear. And now we can also check the packages that are not updated. So we just click all the packages and then put in without we make a plain function that means just that, and then we enter. So it tells you the packages that are here that are all that need to be updated. But if you need to update these packages, you just need update, because sometimes when you run a function and then it tells you that this package is not updated or this function is not it's not available, this kind of package which is maybe very old, that means you need to update that package. So we may update all, or we may update a single package. So when we use the update dot function, okay. Sorry, I'm using a different thing. Update dot packages. Okay, so it's already here in RStudio, which I'm using. I'm not gonna run it because it may take a lot of time, but if you do that, then it is easier that way. But so that's it. So when you have loaded the package, you need to know who authored the package. You need to do what we call package description analysis, or reading the description of a package. So what I'm going to do is use a package description function. It is already here. So with R Studio, all the as long as you know the first starting lines or letters, then you're always on the safe side. It will bring for you, and then you cannot make a lot of errors in terms of spellings. So you do update the package. I mean package description. So I'm going to do that, and it will bring everything about this package. And this is the starting point for you to learn more about this package. So you can see the package name is Mars, and it's highly recommended, and then it gives you the version which you installed. So here for us, we have version 7.3, 7.5, and that last updated to 2019. December, but it usually show you the revision and then the graphics. What kind of the graphic platform it depends on. GR device and these packages as well. But then it's also Lattice, can use Lattice and that. And then who authored this package? You can look at them here. You can look at them, the authors, and then the title of their authors, and then that. So having said that, you can look at all that if you want now. So description, you can get this function that has to support Venable, to support Venables and Ripley. Functions and data support Venables and Ripley modern applied statistics with S. You see, because initially R was scoped from S, programming language. So now, when you put in that, it will tell you, you see how this comes in. So that's the starting point for you. But then I'll go back to, you also need, if you are writing a paper and you have this package for analyzing data, you may need to cite. You need to give credit to the author or the developers. So you put in the citation and then still put in the package name, and then it is going to cite for you. And then, but it gives you a warning that this is just automated. You may need to do some kind of editing this. So it was authored by Venables and Ripley in 2002, and this was the modern applied statistics. That's how they called it, and they published it in Springer in New York, and has ICBM this. So if you like that, then you can also look at this. You can also look at this in the Google Scholar and read this article. Okay. So when I go to Google Scholar, I can read this article now. Sorry. You see, I want to be very fast as much as possible. You see, that is it. This is about Venable and Ripley. So you can look at all the kind of stuff. I don't want to go into details of that. So you can look at that kind of stuff. So that's it. But then after you've installed the package, you now need to know more about this package. Apart from that title, there are already predefined codes that are written about these bundled functions together. So what you do is go call help. Go call help and say package. A package is equal to mass. So when you do that, it's gonna give you a description files here, documentation package that you see all of them here. And most cases when you read this description package, it will tell you the data in it. So that's it. And then you look at them as the character function, randomness function. So it keeps on doing that. So these are the functions. It gives you the functions and then what they do and many stuff. Okay. So for instance, I can also call another help function in start package. Okay, let's do this. we say package description, and then we put in spot start. I don't want to dwell on one package for you. Spot start. You say this says, and it is a comprehensive pen source toolbox for analyzing spatial point patterns, focus mainly on two-dimensional point patterns, including multi-type marked points. That's it. So you could know more information about the package you're gonna use. But if I tried the same function, head up into package is equals to spot start, I could get this description, user guide, code, demonstration, and the news. Okay, all this. It gives you the functions, it gives you everything. The function is, and then it describes the functions here. So we're going to look at the functions later. But then another way around is to look at the data which is nested within this package or contained within this package. So what you do is to use data into package is equal to this time around. I'm going to use mass package. I'm going to use mass, but remember I have to make it a string vector, a string. You see, it gives you the data that is in that, and that is the starting point. You want to look at how the data is organized and arranged, which kind of data frames are in, and which class of data do you have in here. So I'm going to use another package here. What I'm going to do is I have vegan package. So I'm going to ask the kind of data which is in the vegan package. You see, it has this and it defines the title of the package. This is how it is called. Then how do you import this data? It is already there in the repository, in the local folder, but then you can not use it directly. For instance, let me show you that you can't. So for instance, if I can say view into Dune, oh, sorry, it might have been there. I'm going to select another one. Let's repeat because I worked with this at night. If I do that, I'm sure BCI, I never use it. View into, right? It is case sensitive. So you do that, it's going to bring an error. That means you have to first import that data, and we use the data function to import that data set. So I'll do data, small letters, into DCI. So it is now, wanting data into BCI, data set BCI, not foreign. Why is it that? I'm not sure about that. Okay, let's do this. I don't want to waste a lot of time with this. I want to demonstrate this. I want to make my videos shorter as much as possible to facilitate many people as much as possible. View into, let's use might and see. Might not fall. Now let's import it data into might. Data set might not found. That means the vegan package. Why is it this not orbit data with experimental variables? I need to find out why very fast. Okay, let's do this. Let's try to do this. Library into vegan. Okay, the package has been loaded. This is a vegan 2.45. Okay, so let's data into might. Data into might. Yeah, okay, the problem is I was not putting the strings. So now that is loaded. That's the problem, was I was not putting the quotes. Sorry, not strings. I was not putting the quotes. So that's it. So now, the most important, the next thing is to look at, to view this data. So now we can view this data. So you can now see how this data is arranged. So you can look at it, and now you can see what kind of data is this. It is a data frame, okay? So it is a data frame. And then you can look at the dimensions of the data. It's a data frame of 70 rows and 35 columns. Alternatively, you can just get the first 5 maybe rows of the data using the head function, and so that it will bring them here properly. You can say them instead of using the view function. So that's it. But then the next thing is for you to look at how to analyze your data, and then you have to look at the function is how they have been documented. So you will do this. You browse the vignettes. You browse vignettes into the package. So we will do this vegan. Yep. So when you to give you the PDF document source and error code. So if you want the reverse analysis in vegan, you look at that. It keeps on describing analysis, and it goes on describing, even writing for you the codes here. Okay, if you want to do ref function, it show you the formula for that we're doing, and then the function for you to how to use it, how to call the function. So after looking at this, you can even go in details of these functions, because you know these functions, you know that these functions are used to do this, this, and this. So you can now call for help. So now, how do you call for help if I want to use a rare function, the rare function in vegan package? How do you do it if I want to do this kind of stuff? So what I would do is I'll go and, for instance, if we want to use alpha, feature.alpha, so we're going to do, we're going to say help into feature.alpha, okay? And we see how it brings now. And when we call help function, it is going to show us the usage, that's how to write it, how to organize it into a sensible arguments. Usage is a group of arguments, how you use it, how exactly you write it here, and then it gives you the output. And then it goes on to describe the arguments within that usage. So for instance, here, X is the community data. Here, if using that, X is the community data. And index is the diversity index, which in this case is Shannon, my, what, and that, and many other stuff, okay? And it go on to describing the details of maybe like Shannon Weiner describing the details, and many other things, details and the principles under which they are used. You can see here is one minus this and this. And then it gives you the reference where this was developed, what was the origin of this, it was developed from this. And then it can also show you further references in relation to that. You can see multi-part analysis at the part and many stuff, okay? You can see Rainy. So it gives you a comprehensive list, and then it gives you an example using the data. And when it show you an example, it's gonna use the data which is in the package, and it becomes very simple because you know the data, how to call the data back and look at the data, how it is arranged. And when you look at the data, then you can see how you organize your data, and then it becomes very simple for you, or simpler, I mean. It's as simple as that. So that's it. So that's how we try to orientate ourselves to the packages which were written by different people. They wrote them, But the good thing or the good news is when they write them, they document everything and the step-by-step process. So you can also go into, for instance, if I'm going to use the PPP functioning Spark package, which is for turning into a point process pattern or XY coordinates, I could say help into PPP, okay? You make sure you put it in quotes. But then I can say it gives me an example direct here. Example of that, PPP. How you do it, you see, it gives you an example. Yeah, just like in Arab base where you can say example into history. Let's say this, if you go example into the histogram function, which is written as hist, it will even give you a lot of stuff. It gives you even examples of that. And the same is with these functions. So when we go back and look at our the one we use for PPA, we can break down a little bit them. You see, it shows you, first shows you how to organize the data. First of all, here we are using simulated data using the runif function. You see, a runif make a data frame of one column and 20 rows of coordinates, and that's the x coordinates and then the y coordinates, and how you transform that into PPA using the PP function, and stuff goes on like that. And it show you example, and when you see the hashtag is the heading or the description of that usage, the usage of that, those bundled arguments together. So that is it. Please subscribe to my YouTube channels. I'll be updating you every time, from time to time, about how to use R. Thank you very much.